And welcome to Land Tamer Stream on this Saturday evening. It's been a few Saturdays since I've actually streamed on a Saturday, but yeah, I have been working today, day 434 of the journey towards that CCIE routing and switching number. Hope everyone's having a good weekend. We've been working on QoS and we're rounding out. I have to say we're getting there. So I'm gonna do. I was about to do another lab, and I thought, well, I can stream this one. I think. I may have to break away in a minute to help my wife with something. Kind of depends on some timing, but as far as I know, I should be able to get this lab knocked out. So, and do it on stream, which is cool. But yeah, still catching up on flashcards. I didn't do any last night. I ended up going to a hockey game last night. So yeah, had a little fun. It was cool. Hung out with some friends and had a good time. We lost in overtime, but that's all right. So I've got about, I guess, still about 100 cards to catch up on. We'll be jamming on those hopefully this weekend as much as I can. Also, I did a lab earlier today already. So what I've tried to do on some of these labs is when I'm still kind of learning concepts, is I'll do a lesson from Network Lessons. So QoS pre-classification is brand new to me. Excuse me. So I have never done anything with this. I mean, I understand sort of the concept, but I've never performed it before. So just to kind of learn the options, I ran through a networklesson.com lab on pre-classification. Did it here on my local machine, and I'm looking to the left because I'm looking at my at the workbook. Yeah, I finished some of these yesterday, I think. The policers. So I got through these policer labs. Not too bad. I was able to get through most of those. I think I'm still unclear a little bit on when you would use, well, you know, there is also policing by percentage and also the burst sizes for policing. That's a little, I guess I'm a little not unclear. I mean, I kind of understand how it works, but just figuring out the formulas, it can be challenging still. So I'm going to need more practice for sure. And maybe make up some flashcards for that, like little exercises on, you know, calculate the burst size for this, calculate the burst size for that when shaping or when policing, etc. But yeah, it definitely will take more practice. We got through all these, so I've got two more before we hit the security labs, and that is QoS pre-classify, which I'm about to do. Yeah, two labs left. So let's knock this out. I've already got my EvenG Pro lab running here locally. And let's see, let's move this onto the main screen. Hope everybody's having a good Saturday. It is May the 4th, by the way. For some, this is like their biggest holiday. I did this morning watch, I rewatched The Last Jedi. I try to at least watch one of the Star Wars movies on May the 4th. May the 4th be with you. So, may the 4th be with all of you as well. But yeah, QoS pre-classification. This lab, let's go ahead and put the requirements here. And again, standard disclaimer, the lab I'm about to do is from the INE workbook. I don't show the workbook. You can buy it at INE.com. Highly recommend it. It's a great workbook. Don't show the contents on the screen. It's not my lab, it is their lab. So, but anyway, definitely check it out if you want to see the explanation, the verification, the do the labs yourself, etc. Get my cord straight here for my mic. Yeah, requirements are we're gonna have a GRE tunnel between R1 and R6 and use their V146 as underlay. And that's cool. That's on the same segment. So we're actually going to fire up here. Oh, did it say? It did say router 1 and 6, not router 4. That's okay. We'll kill the router 4 in a minute. But man, that Last Jedi is such a good movie, even upon subsequent viewings. Route traffic between L0 subs using tunnel with static. Sure enough. Limit rate of traffic out R6 V146 to 10 megabits per second. You have to do this because obviously if we're going to see the results of applying pre-classification, we have to have some sort of policy, and the policy is not really going to matter a whole lot here. We can power that one off, by the way. But yeah, we'll put a policy. It could be shaping, it could be policing. We'll probably do shaping. Oh, wait a second. It's saying configure router 6. So we want to guarantee 3 megabits per second of priority bandwidth. So IP traffic. Okay, guarantee 3 megabits per second of bandwidth. IP traffic between L0 subnets marked with DSCP-EF. Okay. All right, so the configuration is going to be, let's say, router 1 and router 6. We will say interface tunnel 0, source interface GI 001, GI 01 146. Well, let's just say source tunnel source, and it's going to be 151.146.1. Tunnel destination 6. It'll be GRE mode by default, so we don't have to put that. IP address can be whatever, right? This could be 192.168.16.1. Okay, and then we'll do a static route, IP route. Let's see, it's going to be 150.1. What are the loopbacks? I don't remember having done those in a while. Well, router should be up by now. Show IP interface for 150.1.1.1. Okay. IP route 150.1.6.6. 205, 205, 205, and the next hop will be 151.146.6. Pretty much going to repeat this on router 6. Tunnel source B.6, tunnel destination B.1, and IP address will be 16.6. IP route 150.1.1.1 will be 146.1. Okay, let's just try this, make sure a tunnel comes up and works correctly. Tunnel destination configured fill and tunnel. Let's see, interface T0, tunnel mode, GRE IP. Tunnel destination. Interesting. Well, what is the default mode? Oh, MGREIP. Okay. It already has a tunnel interface, doesn't it? Right. Okay. Well, that's okay. So we just busted our our production configuration. Let's make a new tunnel. Tunnel interface T100, and we'll say no interface T0 because we're not going to use that anyway for this lab. T100. Yeah, let's do that. There we go. Now router 6. Yeah, because the default mode show run interface T0. It should be unicast GREIP. Or not unicast, but hardware's tunnel, encapsulation tunnel. Let's do a show run all. Uh, it's kind of annoying. Okay, tunnel 100. GREIP, yeah. Okay, so tunnel should be up. Ping 150.1.1.1. Source T100. Yeah, okay, good. Ping 192.168.16.1. Yeah. All right, so tunnel is up. Look at the rest of our requirements then. Limit rate of traffic out of R46 V1 for 10 megabits per second. So limit that. Leave it up to INE to be vague and sneaky. But anyway, we'll say limit is shaping. That's generally what you're going to do out of interface. So we'll say, let's go ahead and do our classification. So do on router 1. We're going to have a priority queue. Class loopbacks, class map. We need an access list. Access list ACL loopbacks. IP access list extended. Permit. This is guarantee leaving the interface. So if it's leaving the interface, the destination will be permit IP any host 150.1.6.6. Class map loopbacks, match, access, group, name, ACL loopbacks. policy map, policy child, class loopbacks, priority 3 megabits per second. Or we'll just say 3 meg. I believe we can do that with the priority command. Oh, we only want to match traffic. We want to match all loopbacks that match this access group and match DSCP EF. Yeah. Policy map, policy child, class loopbacks, priority 3M. And then we want to do a policy map, policy parent, class. I can never remember if it's class default or default class. I think it's default class. Class default class, shape, average, 10. And this is in kilo space bits. I'm kind of making fun at the disparity. I was joking on this on my last stream about how whoever did these parsers, man, you know, if it's policing, you have the option. You could do whatever number in M or K or B, but if you're doing shaping, you can only do in kilobits, kilo space bits. And if you're doing bandwidth, it is in bits. Yeah, why there's such a disparity. It's almost like it was, I'm sure it was unintentional, but maybe it was intentional. Maybe there's some deep dark science that is just beyond the likes of those of us of lower intelligence to understand, but I doubt it. Shape average, service policy, policy child. Cool. And then we're going to do, now we're not talking about pre-classification yet. We're going to insert that in a minute. But then this is going to be on interface. It's telling us specifically that we have to apply the shaping policy to the interface outbound towards R4. Out of the physical interface. So we're going to say interface JS01146 service policy output policy underscore parent. Okay, so this is, we would say, normal circumstances. All is well. We are going to run into a problem here, though. And let's just configure it this way and kind of demonstrate the problem. So we'll say we'll go back to R1. Let's see if our policy statements work the first time. Wouldn't that be awesome? No. Oh, excuse me. It's priority. It's kilo space bits. So it's 3, 1, 2, 3, 1, 2, 3. This is one of those moments where you just... Okay, I think what has happened here... Oh, it is kilobits. Okay, 3. So 3,000 kilobits. So annoying. Parent policy. Okay, it's not. It's class default. I made a card on this. Just so I could remember and discontinue making, hopefully, this mistake. And then we'll do the interface. Okay, what went wrong here? Shape average. Keep your cool. Keep your cool. Class default. Shape average. Okay, so it's shaping where I can use 10 megabits per second. So 10 meg. Service policy output policy underscore parent. What was wrong with this? Oh, there was an exclamation point there. All right. Jeez Louise. I may stop using those. All right. So what should happen here is if we do some pings and we mark them, ping, caps lock, why do you keep coming on? Ping IP, target IP address 150.1.6.6. Repeat, datagram size, timeout, extended commands, yes. 150.1.1.1. Type of service should be EF. Let's see what it did show. Policy map interface J0 1146. Okay, so we had 5 packets. Let's see if we could do a PCAP here. Let's capture inbound. So policy child, loopbacks. We have 0 packet matches, okay? And that is what we should expect because these this traffic will change from a ping to a GRE packet when it goes through the tunnel interface and out the physical interface. So that won't work, right? Because it's not going to say, well, actually, let me think about this. So if I think that might be because the destination, yeah. So when it's encapsulated, it will get to the physical interface. Granted, I think it will retain its marking, but the destination interface is going to be different. or destination address in the outside header is going to be 155.146, 155.1.146.6. So the GRE tunnel should copy the DSCP code, EF, to the outer header, which is fine, but this has to match all criteria, and the priority command will only apply to when the destination is the loopback itself. So it will not be prioritized. As we can see here, yeah, there are no packets that match. And we would want, this is an example of a packet we would want to match. So the solution for that, there's two ways to do that. And one is to put, well, let's do another capture here so we can see this. So we're going to do a ping, another ping. 150.1.6.6. Yes. 150.1.1.1. Type of service EF. I think I may not be using the correct type of service. Let me see if that translates. Well, if it's not going through the tunnel, it could be a problem. Okay, yeah, it's best effort. Okay, we got a couple of problems to solve here, I guess. Oh, this is ingress, right? Yeah, source and destination. All right, so when I do EF, I need to figure out the correct code. I guess this is looking for, in your ping, when you do type of service, that's a TOS byte. So it wants the binary value for that. So that'd be 101. Let's see, 46 is going to be 1632 plus 8 is 40. So this is the binary value for the TOS byte. I think we had 00 here. I think this is 56. Let's see. So this will be, no. Man, I always get stuck on this conversion. Expedited forwarding. 46. Pretty sure. Let's just do 46. IP 150.1.6.6. I don't know why I'm drawing a blank on that right now. Yes. 150.1.1.1. Type of service, 46. Wish there was an easier way to do that from the CLX without having to hit enter too many times. All right, so we have some more pings. You got this. Hey, Big Abe, how you doing, man? How are you? DSCP unknown. Okay, what is the DSCP? Okay, it's all right. I think it is 46 with 2 zeros. So what that means is I think I had it. Yeah. So this would be 32 plus 8 is 40. Yeah, that's 46. Then we add the 2 zeros and convert that. Okay, that's the way I was doing it in the beginning. So this would be 128 plus 32 plus 16 plus 8. So that's 160 plus 16, 176, 184. Is that right? 160, 176, 184. Okay, let's try that. Ping, P. Okay, going back to our capture. EF, okay. Man, I need to practice that some more. So now it's marked expedited forwarding, which is good. It is not taking the tunnel though. So let's look at our, first of all, let's assume that show policy map interface J0146. Okay, so there were 5 packets here. So our policy looks good now. We confirmed our policy. We confirmed our marking using ping. The priority looks correct. However, it is not taking the tunnel. Show IP. And I thought I created a static route. Show IP route static. Tunnel is up. But I did the wrong route statement. I did. Okay, show IP interface brief. Show run route. Yeah, but I put the physical interface address on there. I did. My bad. No, IP route 50.1.6.6. It needs to be IP route 150.1.6.6 to the tunnel interface IP, which is 192.168.16.6. There we go. Now, let's do the same ping. Ping 150.1.6.6, source. This should show up as GRE now. And it does. Okay, so now we have the problem that if this hits the outbound interface, it's looked up by the policy map, and it's going to see that, you know, is it marked with EF as a DSCP, and is 150.1.666 the destination? And it's not, because the outer header is this. Let's make sure that the expedited forwarding is still copied to the outer header. That part should work. 150.1.6.6. Oops. Got ahead of myself. Ping IP 150.1.6.6. Ingress ping no. Source 150.1.1.1. Type of service is 184. All right, so now we should see. Okay, it is EF per hop behavior. That's cool. So that gets copied to the outer header. That's fine. It would not in the case of like an IPsec tunnel, right? But the destination address does not match our service policy. So if we look at show policy map, it should only still have 5 packets matching, which it does. So our priority queue, it will basically will not be used. Let's clear counters. Okay, 0 packets. So now, let's fix it. And there's 2 ways to do it. The one I'm going to use is on the tunnel interface, one simple command, QoS pre-classify. And what that will do is put like a pseudo header in memory, so that when it will be checked as traffic leaves the interface, and it will match now. So let's do another ping. Protocols IP 150.1.6.6. Extended commands yes. 184. Success rate, show policy map, interface GI0, 146. And now they match. The other way we could do it is to apply a policy to the tunnel interface itself. But to me, that seems to be more complicated. But let me check this with the answer and the answer key on the lab, see if we got it. No source, the IP unnumbered. No. Why would you do it that way? So they're choosing to do it without using QoS pre-classify. They're actually showing 3 methods of doing it, and yeah, so I mentioned 2. QoS pre-classify, applying a service policy to the tunnel interface itself, and they're introducing something called TOS reflection. Which I think is a horrendous way to try to do it. And that method is not covered in it is not covered in the QoS book It's not covered in networklessons.com. Only in INE. So, I don't know, INE. Why? First of all, I try to stay away from IP unnumbered. Again, the teaching methods here leave me a little bewildered. Why this would be, that should be like a separate lab. If you want to teach TOS reflection, do that as a separate lab. Like, you're not even really trying to teach the QoS preclassification here. There's so much, I don't know, I'm not saying I'm going to do it, definitely not thinking about it, but there's such a gap in good labbing and good instruction material for QoS that it leaves me a little bewildered. Anyway, this is correct. This is working. You know, I think at the end of the day, in a real lab, unless they gave me a restriction, like you cannot use QoS do this without using the QoS preclassify command, I could still do it. I could do it by applying a service policy to the tunnel interface itself. If they ask me to do it without applying a policy and without using QoS preclassify, I may just take a gamble on that, because to do IP unnumbered, because what you have to do is you have to yeah, I'm not even going to go over this method here. Oh, sorry. Yeah, I'm gonna have to help them here in a minute. Turn notifications off. So anyway, we got this lab done, which is great. Good method. I also got some practice on converting the EF to binary, for example. Good stuff. And I have one more lab to do in QoS. And there's a lot of explanation here. I am gonna read through this off stream, so I'm probably gonna wrap it up there. But I just want to say, I hope everybody has a great Saturday night. If you're labbing, aka studying, wish you the best, and I'll send you some good bits out of the ones I have. Thanks for hanging out. And, you know, we'll be labbing some more tomorrow. Now, tomorrow, if I'm not labbing, I'm assuming that I'll be finished with QoS, or that I will finish the last lab of that on stream. Then what I'm probably going to do is do a review period. May redo the foundation lab before I go on to the next section, which is security. But yeah, thanks for hanging out. You can follow me here on Twitch, on Twitter, of course, at the Landtamer, and also on YouTube, Instagram, and of course out on Discord is where we have a lot of discussion. And I need to catch up on some Discord messages. I'm gonna do that tonight. Flashcards, grinding every day, and we shall see you all tomorrow here in the Landtamer stream. Thanks very much.